I'm Graham Baker, and I will present the BioHybrid Aviation project I'm working on here at NASA Ames. The objective of this project is to grow the most commonly broken and replaced drone components out of mycelium, mainly being the chassis and the propellers, and then to embed the electrical components of these drones into the chassis of the drone. And mycelium is the underground root network of the mushroom, which have hyphae like roots growing into each other, which can form a structural material that we can utilize in the lab. And NASA's motivation for this is to not have to rely on a supply chain while in space, but be able to make these materials in situ autonomously by themselves in space. So the goal is to send fungal spores and algae, which aren't massive and don't take up much volume, to space. So that'll be very cheap to get out of Earth's gravity well, and then to grow algae through photosynthesis, and then feed this algae to the fungus along with food wastes, human wastes, and regolith from Mars and the moon in order to form this mycelium material. So there's no need for big industrial machines. And on Earth, where we have these machines, it's also important to have autonomy so that we can produce these materials anywhere we want. We don't have to rely on shipping. We don't have to rely on foreign adversaries for materials, but we can do it anywhere we need to. And this is a national security issue because these oil refiners can be targeted by adversaries, but also it's environmentally friendly because of swarms of drones that are becoming more popular as they go down and decompose and their propellers break. It's important to also keep in mind the environment. So I have multiple steps for my process, and the first thing is to prepare the substrate. You mix the materials together and you form jars and bags. You sterilize them in the autoclave, and then you inoculate the jars with antiseptic technique in a laminar flow hood. You take slices of the Ganoderma sessile that we decided on, and you add them to the top of the jar, wait for them to myceliate to the bottom, and for the jar to become white, as you see in this photo. Then you add the jars to the bags, and the bags myceliate and produce this material. And I modeled the chassis in Onshape, and I tried to make it structurally sound with these arms that aren't going to fall off, but also enough lifting area for the propellers, as you can see with these circles represent the propellers, to push air not on the chassis, but on the ground to lift it off the ground. And you see here the mold I made easily comes apart. And then I stuff the mold with the substrate. And as you see right here, I just shove the electrical components right in there, and I bury them in mycelium so that they don't come out once I turn the motors on. Then I grow it for a few days, take the mold off so that the mycelium can breathe and form a skin around it that keeps the woody substrate in, as you see right here. And then I dry it out so the mycelium stops growing. Because once it dries out, it enters a coma state. And then I coat it with shellac so that it doesn't rehydrate and become alive again. Because this is very interesting, because if the drone goes down, cracks, a fracture propagates on the propeller, then the coating is broken in that one crack, and moisture is able to get in, and it can heal itself. It can regenerate and then heal this crack, and then you still maintain the structural integrity of the chassis or propeller, which is very interesting. And I use a similar approach for my propeller. However, I want a small substrate size to have a high resolution for my mold because I want a specific airfoil shape. So I modeled the airfoil shape in XFLR5, and it helped me decide on the NACA 224 airfoil or 4412 airfoil, and I modeled it in 2D and 3D to see the optimal twists on the propeller blade and the optimal thickness. So with this in mind, I was able to make a model on Fusion. So I had 11 different airfoil shapes that I downloaded one airfoil shape and I sized them to 11 different sizes, and then I lofted them together and twisted them 1.5 degrees each as according to my XSLR5 data. And then I created a mold out of TPU, was very bendy. I was able to stuff this mold and then bend it to be able to take the propellers out once they've grown for a few days in the incubator. And then I dried them out. As you see here, it's a good resolution. And I was able to paint them with shellac to maintain their shape and integrity and not rehydrate and grow into crazy shapes. So thank you for coming to my presentation, and I hope it opened your eyes to the world of mycelium and what it can do. Thank you.